Okay, welcome. We're trying to go ahead and figure out what x is. We are told that AB is the midsegment. The midsegment means it's half the length of the side that it's parallel to. So our midsegment here is half of the side that it's parallel to, which is this. So it's going to be 1/2 of that 34. So we get on the left side 3x minus 1 is equal to 17. Then we can go ahead and add 1 to both sides. We get 3x is equal to 18. Divide by 3, and we get x to be 6. Now, that's what x is, but we also need to find what the length of xy is, this whole length. Since we have a midsegment, we know that this part right here, which is 6, has to be the same as this part right here, which is 6. Well, if the upper part is 6, the lower part is 6, that means the whole thing here is 12. So we know xy is 12. So looking at the upper right one, we know it's a right triangle. In a right triangle, to relate the three sides, we can use the Pythagorean theorem. The Pythagorean theorem says leg squared plus leg squared equals your hypotenuse squared. Remember, your legs are those that come into the sides of the right triangle. So this would be a leg, and this would be a leg, because they come into the side of the right angle here. So all we have to do now is the Pythagorean theorem. We can go our leg squared plus our other leg squared, because remember the legs are the ones that touch the right triangles, or right angles, equals our hypotenuse squared. So now we can go ahead and work this out. 7 squared is 49 equals 256. Oops, lost my pen. Oh yeah, you guys probably like the different colors. So we subtract 49 from both sides, and we get 207. Now we need to go ahead and take the square root, excuse me, square root of both sides, and we get x to be the square root of 207. Well, at this point, we should go ahead and look for factors of 207 that are perfect squares. Now, if we do a factor tree, we know that this is a 9 times a 23. 9 is a perfect square, so I'm going to write this as the square root of a 9 times 23 inside of my root. So now I can take the square root of the 9. You guys know the square root of 9 is 3. I can't do anything to the square root of 23, so it's going to stay on the inside. And so I get 3 times the square root of 23 for my missing side. So basically here we're doing the converse of the Pythagorean theorem. We're trying to decide if this is a right triangle. So you have to go the shortest side squared plus the second shortest side squared equals your longest side squared. We can't say leg squared plus leg squared equals hypotenuse squared because we don't know if it's a right triangle. So you need to figure out the shortest side and then the second shortest side. Now you guys could probably estimate this. If you estimate this, you get about 10.6 here on the bottom side. 10.8, sorry, and then here you get about 5.1. So we know these two sides with the roots are the smaller sides. So we can go the two smaller sides, those that we just worked out with the roots. We can go root 18, 118 squared, plus your other short side squared. And then we are wondering if that's going to be equal to our longest side squared. So the square of your square root, they cancel each other out. So we get a 118 here plus a 26 because your square cancels out your root equals 12 squared. So 12 times 12 is 144. So now we're still not sure if this is equal. We need to add together the left side. And so if we add together the left side, we get 144. Also, on the right side, we get 144. Since we get the same thing on each side, it does hold true, so therefore it is a right triangle. Now, if what we had over here, if this did not end up being a true statement, if you did not get the same number on each side, then it would not be a right triangle.